All right, example 6, and we had decided that we were going to round to the nearest tens place. And the point when we had gotten to last time was that we had said we were going to make this then a 90 and a 30 using rounding to the tens place, and we had an answer of 60. And part B was going to be my front end estimation. And my front end estimation means I'm still looking at the same place. What I'm going to do instead of looking at the next value and deciding up or down, the next value and everything after it automatically becomes 0. Okay? So instead of looking at the 89, 47, and 47 hundredths, I simply look at the 8 at the beginning in the tens place and I write down 80. I ignore the rest of them. Doesn't matter what they are. It makes no difference at all. They all go away. And the same thing on the second one. I look at the 32 and 1600ths and I ignore everything after the 3 and turn everything else into zeros. And when I subtract this one, what do I get? 50. All right. And then part C, if you will, it's not really listed like that, but part C is that we're actually going to compare how close they are if we really subtract them. So 89 and 47 hundredths minus 32 and 16 hundredths. And we'll go from left to right. And so if I subtract 7 minus 6, I get 4 minus 1, 9 minus 2, and 8 minus 3, 5. All right, so my answers are reasonable estimates, right? They're close to the 57 because I had 50. I don't know why I put a dollar sign on that. Maybe because it looks like money. I'll take the dollar sign off. So I had 60 for my first answer, 50 for my second one, and the actual subtraction of the two is 57 and 31 hundredths. Yes?
So when you have I think you said this, but with the front end estimation, if it's like what place it is, you always do the one furthest to the left, like if it's hundreds and thousands, or is it always?
It's your choice. It's your choice. So when we decided on this problem that we were going to do rounding to the tens place, we also were going to do front end estimation to the tens place. So whatever we decide, we're just going to decide the same thing for both the problems. If I had done this problem with the units one, then I would have written down 89 and 32, and I would have subtracted those. But if I had done it for the units place actually it would have been 89 and 32 on either one of them for either rounding or for front end estimation on that one. They would have been the same on this one. Yeah. Okay, last example. Example number 7. A student tries to calculate 999 thousandths raised to the power 10,000 on a calculator. And the student finds that the answer is 4.5173346 times 10 to the negative 5th. Is that a small number or a big number? Very, very small, right? Okay. The student wonders how it could be that a number like 0.999, which is very, very close to the number 1, when it was raised to a power, could actually become a number so close to 0. And the question is, how do you respond? Why would that happen? Or how could that happen?
Each time it's getting farther and farther and farther away from 1 because you may have 999 times 999, which ends up less than 1, and then farther away from 1, it just keeps getting bigger.
That's a very good point. That's definitely something we're going to write down on this one because that's the key issue here, is that when we multiply something together that's smaller than 1, the numbers get smaller than they were before. Right? Okay? When you're multiplying by a value between 0 and 1, which is this number is, the value gets smaller. Now this one gets very, very small, right? Why would that part be happening? That exponent's huge, isn't it? Like 10,000? So we're going to do just a little bit of a trick with your calculator on this. So grab your calculator out. I want to show you how cool you can do. And you can actually show a student how this is working. And then after you get your calculator out, I'll write down a few of those features that you guys have told me. So issue number 1 is about multiplying by small numbers. Okay, so this is the first thing. This is what Andrew said. You multiply by something smaller than 1, and it gets even smaller than it was before. And the second issue is that our exponent is very large. Hence, we are actually multiplying this value by a smaller value. Now let's say by a value less than 1. $10,000 times. I'm not encouraging you to try this 10,000 times. I'm going to show you something different, I promise. Okay, no matter what kind of calculator you have, this will work for you, okay? What we're going to do is when we write things down on the screen, on my screen right here, and you write them down on your paper, you're going to have to abbreviate the number, but you're never going to make your calculator stop keeping all of the decimals it keeps, okay? So don't hit clear or anything like that in your calculator. You want the calculator to keep reusing all the decimal points, all right? Here's the thing you're going to do first. You're going to take that .999 that the student was using, and you're going to multiply it by itself or square it. So if you have a squaring button in your calculator, that's what I recommend. So just push .999 and hit squared. And we're going to write down the answer to 6 decimal points on my screen here. What do you get? Fabulous. Smaller. Still a lot smaller, right? But it's smaller. Okay, where your calculator is right now, I just want you to hit the square button again. So now think with me what this is really doing. When I square something twice, what am I doing? It's the 4th power. Am I adding exponents or am I multiplying? Do you remember? This one's hard to see because either way I would get 4, right? It's actually multiplying. Yeah. Because what we're actually doing is we're doing the .999 squared. That's what I just did. When I had you hit squared again, it took the previous answer and it squared it. All right, so what do you get on this one? 49,600,5996. Okay, 5 at the end or 6 at the end, it's not a big deal because our calculator's keeping this score anyway, right?
Yep.
Okay, what do you think I'm going to have you do again? Square it. So this time now, it's going to be different. Am I going to multiply? Am I multiplying the exponent by 2 or am I adding it? I'm multiplying it. So this is actually the power of 8 that you're about to get. What do you get?
1992027.
Awesome. We're going to do this a few more times. Hit that power 2 again. I've got the 16th power now. Do you have finally a 98? 981, I'm sorry, 984. 119. Okay, we're going to do the power of 2 again. This is actually the 32nd power now that you've got written down. Awesome. Square it again. We're going to do it about 5 more times or something, I'm not sure. I want to show you something cool. Yeah, I'm serious. Promise, it's going to be worth it. Maybe. All right, 9-3, what's next? 7-4-7-5, okay? Again. We are out of the 90th percentile, aren't we? We're out of the .9s, okay? Okay, let's try it again. This is actually going to be the power 256, in case you weren't sure what happened next. What does this one become?
77404.
There we go. Cool. We're out of the 8s. We jumped out of the 8s fast, didn't we? All right, yeah, we're multiplying by more. Yeah, you're right. It's 512 next. What's this one?
59914.
And we skipped right over the 0.6s. This is our last one, okay? What's this exponent? Do you guys know? 1024. And where are we?
535,897. Man, let's just keep going.
I pause here for a couple of things. For one reason, I want you to see that it becomes quicker as you go, because and somebody said it's because we're multiplying by something much smaller, and that's exactly right, because when we square it, that is, we're multiplying it by itself. So like on this step, I'm actually multiplying, 0.93 times 0.93, right? But once I get down to here, I'm multiplying 0.59 times 0.59. That's way smaller than it was before. The other reason I kind of like to stop here is because this power, 1024, is actually 1/10 of where I was actually supposed to go, isn't it? About. I'm supposed to be going to a power of 10,000. So to the power of 1,000, I'm already at about 1/3 of where I started. I started at about 1, and now I'm at about 1/3. So it's an interesting sort of a feature. And this is something that you could show a student very quickly on a calculator. You don't have to have them write this table down, right? All they have to do is square it multiple times, and they can actually see this creation of these values very quickly becoming smaller towards the end.